All right, beginning our unit here on solving linear equations. First lesson we're looking at here, starting with our warm-up. We got a few equations to solve. So for number 1, we have 1/3 x equals 8. So the inverse property we're going to use here is we're going to multiply by the reciprocal to cancel out the 1/3. So multiplying by 3 over 1. And that leaves us with x equals 24. 8 times 3 divided by 1 doesn't change it, so just 8 times 3 gives you 24. Okay, for the second one, we have 5 plus x equals 12.7. So we got one step here, which is just subtract 5 to move it to the opposite side of the equation, the inverse operation of having a positive 5 there. So we end up with x equals 7.7. For number 3, we have 2x minus 9 equals 6. So we're going to first add 9. Inverse operation of having the minus 9 there gives us 2x equals 15. And then we are going to divide by 2. And we get x equals 7 for our answer. So x equals 7. And then our last one here. See if I can squeeze it in down here. Number 4, we have 12 plus 2x equals 3x minus 1. All right, so now we're seeing variables on each side of the equal sign. So we're going to want to move all our variables to one side. So I'm going to subtract 3x to move that over to the left side and combine that with the 2x. So now we have 12 minus 1x, 12 minus 3, or 2 minus 3, equals negative 1. And then we're going to subtract 12, and we get negative x equals negative 13. Now, we don't want negative x, we want positive x. So we are going to need to change our signs, which are essentially we're dividing by negative 1. But if negative x equals negative 13, positive x is going to equal positive 13. All right, next page. It says equation creation. An equation is a mathematical sentence that uses an equal sign to show that two expressions are equivalent. When one of those expressions contains a variable, you can solve the equation. Consider the equation x equals 2. You can substitute the value 2 for x to create a true statement, 2 equals 2, because this is the only value that makes the statement true. 2 is the only solution to the equation x equals 2. By performing the same operation on each side of an equation, you can create more complex equations that have the same solution. Okay, so this is make an example of the idea of inverse operations. As long as we do one thing to one side of the equation and do the same thing to the opposite side, we create an equivalent equation. So it says, choose any constant, add that constant to each side of the equation. So if we have x equals 2, let's say I want to add 3 to each side. Now I have x plus 3 equals 2 plus 3, which is 5. So I've created an equivalent equation there by adding the constant 3 to both sides. Okay, for b, now we're going to choose any constant other than 0, and we're going to multiply each side by that constant. So I'm going to take that equation we just made, x plus 3 equals 5, and I'm going to multiply it by 4 on both sides. So now we have 4x plus 12, 3 times 4 gives you 12, equals 5 times 4, which gives us 20. So 4x plus 12 equals 20 would be still an equivalent equation. And then C, we're going to choose any number other than 0 to represent a in the expression ax. And we're going to subtract the term ax from each side of the equation you created in part B. So in other words, we're going to subtract another variable term here. So I'm going to make it, let's say, 2x. So if I take our previous equation, 4x plus 12, and I'm going to subtract 2x on each side of that equation. And now I can combine the like terms on the left side. 4x minus 2x gives me 2x. And now I have 2x plus 12 equals 20 minus 2x. Again, we made it more complex, but it's still an equivalent equation. And then for D, choose any constant other than 0, and we're going to divide each side of the equation you created in part by that constant and then simplify it. So let's divide each side of this equation by 2. Make it an easy one since all those numbers look divisible by 2. So if we divide the left side and the right side by 2, we're left with x plus 6 equals 20 divided by 2 is 10, minus 2 divided by 2 is 1, so minus 1x. Okay, so it says have a partner solve the equation you created in the questions and verify that x equals 2. Okay, so if you want to try to pause the video and see if you can solve that equation, now would be a good time to practice that, and then unpause to check your work. So if I take that equation, and I'm going to move all my variables to one side, so I'm going to do plus x, move that to the left, so now I have 2x plus 6 equals 10. Then we need to subtract 6, move that to the right side. So 2x minus 6 equals 4, and then divide by 2, and you'll see that we still get x equals 2, which is where we started with. All right, so using properties to justify a solution. So these are all our properties of equality we use when we're solving an equation. The addition property tells us if we add the same term to each side, it remains equal. The subtraction property tells us if we subtract the same term from each side, it remains equal. The multiplication property of equality says if we multiply each side of the equation by the same term, it remains equal. And then last, division property, if we divide each side of the equal sign by the same term, it remains equal. As long as we perform the same operation on each side of the equation, you are producing an equivalent equation. Okay, it says Sarah and Ethan both created new equations starting from the solutions statement x equals 2. Verify that both equations are equivalent to x equals 2 using the given strategy. Okay, for Sarah's equation, make this a little bit thicker. There we go. So negative 3x plus 14 equals 18 minus 5x. Let me rewrite that. All right, so again, we're going to start by moving all our variables to one side of the equation. So I'm going to add 5x, move that to the left side. 5 plus negative 3 gives me 2x now. Bring down everything else in the equation. So all my variables are on the left. I'm going to subtract the 14. Move that to the right, which gives me 4, and then divide everything by 2. And we do see that x equals 2. Okay, if we plug in 2 to that equation for x, it would simplify and we would get a true statement. Okay, I'm going to now, I should have written that under properties equality. So let's flip-flop these. My fault. Thought we were solving it first. So now we're going to plug into for x in her equation and verify that we do get a true statement. So negative 3 times 2 for x plus 14 equals 18 minus 5 times 2 for x. So we're using substitution now. And on the left side, that gives you negative 6 plus 14 equals 18 minus 5 times 2 is 10. So if we simplify both sides, 14 minus 6 gives you 8. 18 minus 10 gives you 8. So we do get a true statement showing that her equation is, in fact, accurate. We do get x equals 2. Okay, then for Ethan, I'm going to erase that to give myself a little more space. And we'll put them on the correct sides this time. So we'll do substitution first for him. We're going to plug in 2 for x and simplify. So on the left, 2 times 2 is 4. On the right side, 5 minus 1/2 times 2 is 1. So we do get a true statement. 4 equals 4. So that matches up. And then using the properties of equality this time to solve his equation, to verify we do get 2. First, we want to move all our x's to one side again. So I'm going to add 1/2 x. So we get 2.5. I'm going to make that 2.5x equals 5. And then divide by 2.5. So x equals 5 divided by 2.5 is 2. So we did verify that both by the substitution and the properties of equality that his equation is accurate. Okay, also some basic number properties that you've been using before. You might not have known the name of them, but helps justify your steps. So the commutative property just simply means with multiplication and addition, order doesn't matter. So if I do, for instance, 4 plus 2 or 2 plus 4, I'm going to get the same result. If I do 2 times 4 or 4 times 2, that order doesn't matter. I'm going to get the same result. For the associative property, you can see that they're showing it with grouping. So if I had A plus B plus C, it doesn't matter if I grouped A and B together or B and C together, as far as if I did order of operations, would it change my result? And that applies to both addition and multiplication too. So if I did A times B and then times C, or if I did B times C and then times A, it's not going to change my result. In the distributive property you've definitely used before, probably that's actually the term you've heard before, is distributive. We're multiplying into our parentheses. So you get A times B plus A times C. All right, so we're going to solve each one of these equations. Now for space, I'm just going to justify it with the reason, saying the reason without writing it out. So for the first one here, we got 24x plus 7 equals negative 4x. Now, there's multiple ways we could start this, but when I'm looking at an equation, I see I have variables on both sides of the equal sign, and I only have a constant on the left. So I'm going to move all my variables to the right because the only constant is on the left side. So I'm going to subtract 24x. So that leaves me with 7 equals negative 4 minus 24 is negative 28x. And we were using our subtraction property there. We subtracted the same thing from both sides. So then if we divide by negative 28, we are going to get x equals negative 1/4 if you reduce 7 over 28. 7 goes into 7 one time, and 7 goes into 28 4 times. And it is positive over negative, so it remains negative. And we were using the division property on that last step. Okay, if we go over to B, first we're going to distribute. And we get 6x plus 3. When we multiply that 3 into the parentheses. Right side, we're just going to bring it down. So we're using the distributive property. Now I'm going to move all my variables to one side. This one, unlike A, has a variable and a constant on both sides. So if that's the case, I like to move all my variables to the left side. So minus 4x. It gives me 2x plus 3 equals 6. And then I'm going to move all my constants to the right. So now I'm going to subtract 3. And that last step was using the subtraction property, and we're using the subtraction property again. 6 minus 3 gives me 3, and then I can divide by 2, and I get x equals 3 over 2, or 1.5. In that last step, here we were using the division property. All right, and then C here. Okay, the right side is showing us that associative property. Doesn't matter how we group those. We can combine like terms, whichever way we see fit as far as the terms that can be combined, and it's not going to change our result. So for 1/2 x, I'm going to change it to 0.5x for a variety of reasons. One, space. Takes up less space to write the decimal than the fraction. So on the right side, that associative property, that order doesn't matter. So I'm going to combine my like terms. 2 plus 1. Or you could say you're using the distributive property of distributing a 1 here, but that doesn't change it either. So 2 plus 1 gives me 3. So now I'm going to move all my variables to one side. So I'm going to subtract 2x on both sides using the subtraction property. So 0.5 minus 2x is negative 1.5x. And then I'm going to use the addition property to add 6 to both sides to cancel out the 6 on the left side. That gives me 9 on the right. And then last, I'm going to use the division property and divide by negative 1.5. And 9 divided by negative 1.5 will give you negative 6. All right, down to 3. It says compare solution strategies by Kaylee and Destiny. What do you notice about the properties of each student? Okay, well, in the first one for Kaylee, her first step, we can see she used the distributive property. Multiplied that 4 in. From there, she moved all her variables to one side. It looks like she subtracted the 8x to move it this side, so she used the subtraction property. And then she moved the subtraction, did the subtraction property again to move the 8 to the right. 4 minus 8 gave her -4, and 12 minus 8 gave her the 4x. And then last, divided by 4, the division property, to get -1. So she distributed first. Okay, this next one with Destiny, it's showing there's more than one way sometimes to solve an equation. So her first step on the same equation was she divided by 4 on both sides. What that did was it canceled out that 4 in front of the parentheses. I should have written it below there. She's canceling it with this 4. Canceled out that 4 on the left side where you didn't have to distribute, and then you could divide the 8x and the 4 on the right side here by 4, and that gave her the 2x plus 1. Okay, from there, she just used the subtraction property and then to end up with our x equals -1. So Kaylee started with the distributive property. Destiny decided to start by dividing by 4 to cancel out that 4. Both are correct. They both got to the same correct answer of x equals -1. All right, it says in the getting started activity, we built equations from x equal 2. In this activity, we are build equations from 2 mathematical sentences and compare the results. So it says, consider the mathematical sentence 2 equals 2. Is there any variable or constant that you could add, subtract, multiply, or divide to both sides using the properties of equality to make this true statement false? Okay, choose your variables and constants to create a new mathematical sentence to justify your conclusion. So it says as long as we added it to both sides, it's not going to change the truth or the validity of that statement. So as long as we provide the same operation to both sides of the equation, it remains true. So in other words, let's say I multiplied by x on both sides. 2 times x equals 2 times x. Well, that's going to stay true. It's not going to change anything. Or if, let's say, I took the original equation, I added 4x to both sides. 2 plus 4x equals 2 plus 4x. That doesn't change the statement, their equation remaining equal to each other. Okay, and then for 2, same thing, but now we're looking at 2 equals 3. Is there any variable or constant you can add, subtract, multiply to both sides using the properties of equality to make the false sentence true? No, we can't. If we're starting with a statement that's not true, 2 equals 3, nothing can be done to both sides with the same operation to make that equation become true. So if I multiplied by x on both sides, 2x equals 3x. Again, that's not true. So we can't do an operation that can be done to both sides and it remain a true statement, an equal equation. All right, on the next page, a linear equation can have one solution, no solutions, or infinite solutions. The equations we solved in the previous activity were all equations with one solution. So a linear equation with no solution means that there is no value for the variable that makes the equation true. And a linear equation with infinite solutions means that any value for the variable makes the equation true. So explain whether equations we created in question 1 have one solution, no solutions, or infinite solution. That equation created in lesson 1, or the number 1, let's say I added x to both sides. So we had this statement. This is the one that we're going to remain true no matter what we did. Well, if I subtract, let's say, x from both sides to try to move those all to one side, we're going to see that our variable cancels out on both sides. So if your variable cancels out on both sides, what we're left with, it's either going to be a true or false statement. If the statement is true, 2 equals 2, what that means is any number we plug in for x would be a solution. So this would be infinite solutions. I can pick any number I want, substitute it in for x, and it's going to be a true statement. Okay, and then the one for question 2, the one that was false to start with, the 3 equals 2. Let's say we added x to both sides on that one and made it 3 plus x equals 2 plus x. Okay, same idea. If we try to move all the variables to one side and subtract x, they're going to cancel out. So we end up with a statement that says 3 equals 2. So if your variables disappear because they canceled out, the statement we're left with, if it's not true, this means there is no solution. There's nothing we can plug in for x that would make that statement become true. So an easy way to think about it is if your variable cancels out on both sides. If we're left with a true statement, it is infinite solutions. If we're left with a false statement, it is no solutions. And then 4, consider the equation 2x equals 3x. Does this equation have one solution, no solution, or an infinite solution? Well, let's try to solve it. 2x equals 3x. So if I subtracted all the x's to put them on one side, I'm going to subtract 2x. That leaves me 0 on the left, equals 3 minus 2 is 1x. So we get x equals 0. Okay, that is still one solution. That just means the only value we can plug in for x to make that equation true is 0. So x equals 0 is our one solution. All right, we're going to skip past activity 1.3. That's something we'll do in class, not something super easy to show you here digitally. And we're going to finish up just writing out the steps here in the talk activity at the end of the operations they use to solve this equation. Okay, well, in that first step, we see the negative 1/3 outside the parentheses of 6x minus 21. They use the distributive property to distribute that in. And the same thing on the right side, they distributed that negative 5. So we use the distributive property. I'm just going to write distributive. Okay, on the next one, it looks like we moved all our variables to the left side. They added the 5x to the left side. So that would be the addition property. And then for the third step, looked like we tried to move all the constants to the right, so they subtracted 7 to move that over to the right side. So they used the subtraction property. And that left them with 3x equals negative 12. And last, they divided by 3, so they used the division property. Ended up with x equals 4. Okay, number 2. They're giving us the properties, and we're going to use those properties to solve the equation. Okay, so the first step says the multiplication property of equality. So it looks like what they chose to do is multiply the equation by 3 to start with. If they're going to use the multiplication property, that would cancel out that divide by 3 on the right side. So essentially the left side, 3 times 5 would become 15x. 3 times 7 would become 21. And on the right side, we would end up with dividing or multiplying by 3 would cancel out the 3, and we'd have negative 15x minus 1 plus 4. Now, that associated property, they're not listing it here, but we are going to end up combining these like terms. And the distributive property already did on the right side. I'm kind of getting a step ahead. Let me erase that because I didn't realize they separated that step out there. Let's do that because that's going to make our lines be off. Okay, so again, the multiplication property multiplied by 3 on both sides and the distributive property all in one. So what they're saying is I'm going to write out that step here. I combined those steps is what happened, and it was going to make our lines be a little off. All right, so there's the multiplication property. So the distributive property on the next step, now they're distributing the 3s is what they're wanting us to show here. So 15x plus 21 equals negative 15x minus 1 plus 4. That canceled out the 3's in the denominator. Now the associative property, they're showing us that we can combine these terms on the right side, combining like terms. So now we have 15x plus 21 equals negative 15x plus 3. Now we can use the subtraction property to move all our x's to one side. So let's say we'll move... Well, let's start with the 21. We'll use this. They're going to say subtraction property. They're wanting us to move the 21 first. So the subtraction property to move the 21, and we end up with 15x equals negative 15x minus 18, 3 minus 21. Now the addition property. That's why I moved the 21 first, because the addition property was going to move the variable. So plus 15x. But that order would not have mattered. You could do either step in any order you want. So if we add the 15x, we're going to end up with 30x equals negative 18. And then last, the division property, dividing by that 30. And when you divide by 30 and we reduce that fraction, what goes into 18 and 30 is 6. 6 goes into 18 3 times. So that's how we end up with 3 in that numerator, and 6 goes into 30 5 times, so 5 in the denominator. So negative 3/5 for our solution.